In this video, we are going to discuss the Ellingham diagram. So, what is Ellingham diagram? How is it useful in metallurgy? So, before knowing the answer for these two questions, we shall discuss some fundamentals for Ellingham diagram. The first one is straight line. The general expression for straight line y is equal to mx plus c. Here m is slope of the line and c is y-intercept. We shall see the direction of some straight lines taking few examples. For example, if the straight line equation is given like this, y is equal to 2x plus 3, in which direction we shall draw this line? Y-axis, x-axis. This C is y-intercept, that is the point where the line intersects the y-axis. This is 3. So 1, 2, 3. So at this point this line intersects the y-axis. Then this 2 is slope. Now we have to see the sign of the slope. The slope is positive and this is the y-intercept 0, 3. If the slope is positive, from y-intercept the line travels right side upward. So this is the straight line. Y is equal to 2x plus 3. Okay. If another straight line has the equation y is equal to minus 3x plus 1. So how we shall draw this line? Okay. So here the y-intercept is 1. So 1. 0, 1 this point. Look at the sign of the slope, it is negative. So from this y-intercept the line travels left side upward. So right side, if slope is positive, from y-intercept the line travels right side upward. Now slope negative, so the line travels left side upward. So we can extend. A straight line can be written in many forms. Now we have taken only y is equal to mx plus c form. The straight line can also be written in another form, x by a plus y by b is equal to 1, where a is x-intercept and b is y-intercept. X-intercept is nothing but the point where the line cuts x-axis, and y-intercept is the point where the line cuts y-axis. For example, if this is the equation of the line, x by 3 plus y by 2 is equal to 1. So how we shall draw? So on y-axis 1, 2, 3, 3, 0. X-axis, sorry, this is x-axis, and y-axis 1, 2, 0, 2. Now we connect these two intercepts, extend. So this is the line x by 3 plus y by 2 is equal to 1. So when the straight line is given in the form x by a plus y by b is equal to 1, we can draw like this. But here we should know how to draw a straight line when it is given in the form y is equal to mx plus c. So this concept first we should know. So next we should know about equilibrium reactions. Let us consider this equilibrium reaction. A plus B giving C plus D. A chemical reaction is said to be in equilibrium when it satisfies two conditions. The first condition is the rate of forward reaction is equal to rate of backward reaction. Second condition, the concentrations of reactants and the products remain constant, not same, remain constant at constant temperature. So the temperature is also constant. At constant temperature, the concentration of reactant and product remain constant. But if the temperature changes, the concentration of reactant and product will change. So indirectly, the temperature should also be constant for an equilibrium reaction. So how the concentration of reactant or product and product change when temperature changes? In an equilibrium reaction, if forward reaction is exothermic, then backward will be endothermic. If the forward in this reaction is exothermic, some amount of heat will be released. At equilibrium, the same amount of heat will be absorbed in the reverse reaction. So the net change is no absorption or release of heat energy. On the other hand, if the forward reaction is endothermic, if some amount of heat energy is absorbed during the forward reaction, the same amount of heat will be released in the reverse reaction. Here let us assume that the forward reaction is exothermic and backward is endothermic. So what happens when temperature changes? See. So forward is exothermic and backward is endothermic. Okay, if we want to raise the temperature, what we have to do? We have to supply heat energy to this equilibrium reaction. When heat energy is given, the reaction will take place in such a direction where heat is absorbed. So we assume that forward is exothermic and backward is endothermic. So in which direction the heat energy is absorbed? Backward direction. So more amount of A and B will be formed from C and D when we supply heat energy to raise the temperature. So amount of C and D decrease and A and B increase due to increasing temperature here if forward is exothermic. Okay. So when the temperature changes, the concentration of AB and CD changes. On the other hand, if you assume that forward is endothermic and backward is exothermic, what happens? When we supply heat energy in the forward direction, heat is absorbed, so the forward reaction takes place fast and more C and D are produced and the concentration of A and B decrease. So when the temperature changes in an equilibrium reaction, the concentration of reactants and the products change. So these 2 points are clear. Okay, next we shall see the thermodynamic parameters of an equilibrium reaction. So we shall take the Gibbs free energy change of a reaction. So we shall write Gibbs free energy change as delta G is equal to delta H minus T delta S. So this is the free energy change of a chemical reaction. Okay, now equilibrium reaction takes place at constant temperature. At constant temperature, what is the change in enthalpy? 0. At constant temperature, we have learned that in thermodynamics, the enthalpy change is 0. And from second law of thermodynamics, we have also seen that for a reversible or equilibrium process, entropy change is also 0. So what is free energy change? 0. So for an equilibrium reaction, free energy change is 0. However, when the reaction is not at equilibrium, the free energy change can also be given by the expression delta G is equal to delta G naught plus RT ln Q, where Q is reaction coefficient, which is nothing but ratio between product of concentrations of products and product of concentrations of reactants before reaching equilibrium. So this ratio before reaching equilibrium is called reaction coefficient Q. So delta G will have some value when the reaction is not at equilibrium, because the delta S is not 0 when the reaction is not at equilibrium. Okay. But at equilibrium, what happens? At equilibrium, delta G is 0, therefore delta G naught plus RT ln K is equal to 0, where this 0 is for delta G. What is this K? At equilibrium, the ratio between product of concentrations of products and product of concentration of reactants is called equilibrium constant K. So delta G naught plus RT ln K is equal to 0 at equilibrium, and delta G naught is equal to minus RT ln K. So this is the relationship between standard free energy change and the equilibrium constant of a reaction. What is this delta G naught? It is the standard free energy change. So free energy change for a chemical reaction at the standard condition. Okay. This standard free energy change can also be written like this. Delta G naught is equal to delta H naught minus T del S naught. So like del G is equal to del H minus T del S, delta G naught is also equal to delta H naught minus T del S naught. What is delta H naught? Standard enthalpy change. Delta S naught is standard entropy change. So delta G naught is related to standard enthalpy change of the reaction and the standard entropy change of the reaction by this expression. Okay, next, for any given compound, the delta H naught and the delta S naught values are fixed, and these values are available in literature. So for a given compound, delta H naught is constant, delta S naught is constant. So they won't change for the given compound or for given reaction. At the standard condition, delta H naught, delta S naught values are common. See, the only variable here is temperature. So from here we can say that the delta G naught value changes with temperature, but delta H naught and delta S naught values won't change with temperature, because in the definition of delta H naught and delta S naught, the temperature is fixed. It is 298 Kelvin or 25 degrees Celsius. But delta G naught, its value will change with temperature. Now this is like straight line equation. Y is equal to C plus Mx, that is Mx plus C, where C is delta H naught, T is X. Though we have negative sign here, but the original sign depends on the sign of delta S naught, that we shall see later. So a plot of temperature versus delta G naught should be a straight line, because it looks like the straight line equation y is equal to mx plus c. By seeing this sign, we should not say that it has negative slope. The sign of slope depends on delta S naught value also. This we can understand later. So these are the fundamentals that we should know before discussing the applications of Ellingham diagram in metallurgy. So this part, the application of Ellingham diagram in metallurgy, we shall discuss in the next class. If you like this video, you can share with your friends. If you want to provide suggestions, you can reach us through the email IDs given or the WhatsApp number 94863 77825. If you want to watch further videos, you can subscribe our YouTube channel. Thank you.